Now if you go for the actual problems, just try to understand this problem what they are giving to you. They have given you, as I have discussed in the formula part when I was explaining you the formulas, that what they give you is they give you the number of days and number of hours worked per each day. The same thing is given here. A department works on 8 hours a shift and 250 days a year, and a data is given to you which consists of three parts. First is product XYZ, number of demand for that products annually 300, 400, 500, and the number of processing time is in hours is given to you 4, 6 and 3. I will repeat once again. They have given you three things. First is product is given to you X, Y and Z. Annual demand is given to you in units of each product X, product Y and product Z. And after that they have given you the processing time. What is the processing time in hours? 4 hours, 6 hours and 3 hours. And what they are asking you is find out the number of machines required. What we are going to do is we are nothing but we are going to use the formulas which we have referred in the previous part. Now if we understand here what they are doing is, just a minute. First of all, the first step in this particular thing is we have to find out the processing needed. We have to find out the processing needed. Now the question arises how to find out the processing needed. If we refer the list of formulas, the first formula is of that only, that is processing needed in hours. What is the formula? Annual demand into standard processing per year. If we look at the problem carefully, we have here annual demand in units also and standard processing per unit also. Means we have both the terms as per the formula. So what we have to do is we just have to multiply it, and after multiplying 300, which is annual demand, with the standard processing per unit 4, we can get number of hours like this. 300 into 4 is 1200, 400 into 6 is 2400, 500 into 3 is 1500, and if we add all this we get processing needed in hours. How much amount of processing is needed in hours? Processing needed means for these three products total number of processing required for converting the raw material into these three finished goods annually, it's 5100 hours. This hours represents the total processing done on the products X, product Y and product Z yearly. Understand this, it is yearly. Now the second step here in this particular problem is we have to find out the capacity of capacity of one machine. Capacity of one machine means, as usual, if you refer the list of formulas, the second thing is we are using the second formula here. The formula goes like this: annual production capacity of one machine is equal to number of hours daily into number of days in a year. I have told you previously only that they have given you that for a single day we are working for 8 hours, and in this way we are working in a year for almost 250 days. So if we multiply 250 days with number of hours each day, that is 8 hours, we get number of hours worked or per year, that is 250 into 8 is equal to 2000 hours per year. And as per the third formula, if we understand in the formula list, number of machines required is calculated by first thing which is unknown in the first formula, that is by adding all the processing needed. We have found out the first thing, that is processing needed. Adding all the processing needed, we have found out the workload per year. So take it in the numerator, and the annual production capacity of one machine, which we have found out by using second formula, we will take it in the denominator to find out the number of machines required, which comes to 3 machines, because the processing needed in each case, if we add, we get workload per year as 5100 hours, and production capacity of each machine, if we multiply 8 hours daily with number of days in a year 250, we get 2000 hours per year. So if we divide both this, we get number of machines required, that is 2.55 or 3 machines. This is the meaning or the way the first problem has to be solved. Now coming to the second problem, they are asking what they are asking us. In the second problem, what they are asking us is they have given us design capacity. I have already told you the meaning of design capacity. Design capacity is nothing in simple terms but a capacity which a company or anybody can achieve if all the conditions are ideal, means we have sufficient amount of resources for achieving the target. It is given to us as 50,000 tons of steel per day. We have effective capacity. Effective capacity means the capacity which we can achieve under actual business condition. The difference between design capacity and effective capacity: in design capacity ideal conditions are there, but in effective capacity actual conditions are there. It is given to us as 40,000 tons a day, and actual output is given to us as 36,000 tons per day. What they are asking us is, they are asking us to find out the efficiency of the plant as well as the utilization of the plant. What is the efficiency of the plant as well as the utilization? One thing is very clear here, that utilization, whatever we are going to calculate in percentage form, as well as efficiency, whatever we are going to calculate in percentage form. Now if we refer the list of formula for finding out the efficiency of the plant, we can use the formula number 4th in the list of formula, that is efficiency of the plant is equal to actual output upon effective capacity. Now if we refer the problem, we know the actual output which is 36,000, and we know the effective capacity, it is given to us as 40,000, and if we divide both this, we get 90% as efficiency of the plant. Now coming to the utilization part, again if we refer the list of the formula, formula number 5th, which goes like this: utilization percentage is equal to actual output upon design capacity into 100. We have both the things, we just have to put the values and get the answer. The actual output is given to us as 36,000. It is given in the question. If you refer the question, it is given to you. Have a look here. If you refer the question, it is given to you as 36,000, and if design capacity is given to you as 50,000. So if we divide both, we can get the utilization percentage as 72%. So what meaning can be interpreted from these two values, that is 90% of efficiency and utilization of 72%, that the plant is operating at 90% of its efficiency, so only 10% is lagging. So we can say that the plant is operated very efficiently as compared to what is expected. And if we understand, or if we try to understand the utilization percentage, it is also quite satisfactory. We cannot say that it is very good, but it is not also unsatisfactory. It is quite satisfactory. There is a difference of almost 18%. If you minus 90 minus 72, we get 18% difference in efficiency and utilization. This is nothing but the meaning of second problem. If you understand this problem, there are 4 workstations given to us. Their number of output units is given to us, and they are asking us to find out the bottleneck center. Now, as I have told you in the list of formula only, that bottleneck center is nothing but any process or any work center having minimum capacity. Now, if we refer the diagram which is in front of you, A, B and C, D. Out of A, B and C, D, A will be the bottleneck. There is slight correction in the study material of operations management. What here there is a slight correction, that in the first part they are writing as minimum capacity, and they are taking C as the work center. But compared to C, A has minimum capacity. C has capacity of 340 and A has capacity of 300. So here the bottleneck center will not be C, but it will be A. There is slight correction in the first answer given here. Now, as I have told you, this is nothing but the bottleneck center. Now, as the answer of first part is different, then the system capacity is also the same as the bottleneck, which will be 300 units. I have told you already the meaning of system capacity. System capacity is nothing but a capacity which is able to produce on a whole, We can produce it on a whole basis. So whole basis means we can on a whole basis, it simply means maximum we can produce this. We cannot produce a single unit more than this. It is the simple meaning of whole, WHOLE. So here the system capacity will also be 300 units. Now if we go for the system efficiency, the formula is given to us in the formula list. If you refer the formula list of my previous video, it is nothing but system efficiency. If you refer the formula, what formula we can achieve, we can use here. We can use the formula number 4, that is actual output upon effective capacity. We can use this for, sorry, actually we can sorry for the correction, we will use the formula number 8 here. I'm sorry for the delay. We will be using formula number 8 from the list of formulas, that is system efficiency is equal to actual output upon system capacity. We know the actual output. What is the actual output? It is 300, and we know the system capacity, it is also 300. So efficiency we can find out that it will come to 100%. It is coming here as 88.23%. Maximum possible output we can achieve is 100%. There is a slight confusion here regarding this. Now the last problem of capacity planning, if we understand, they are asking us to find out the break-even points in the last problem. Out of these 4 problems of capacity planning, the last problem is one of the most important problems, if you understand. Problem number 4, one of the most important problems, goes like this, that a manager has to decide about the number of machines to be purchased. He has 3 options. 3 options are given to him. I am just reading out the question. He has 3 options, that is purchasing first 1 or 2 or 3 machines. Data is given to us. Number of machines are given to us. Fixed cost is given to us, and range of output which will be produced on the 3 machines 1, 2 and 3 is given to us. After the table data given in the table, variable cost per unit is given to us and revenue is given to us. And they are asking us to find out the first point, that is break-even point for each range. I will repeat the question once again. What the question says: there is a manager who wants to decide about the number of machines to be purchased. He is confused regarding how much amount of machinery should be purchased, either 1, 2 or 3, and following data is given to us. Number of machines are given to us. Fixed cost incurred for each machinery is given to us. Corresponding range, variable cost per unit and revenue cost per unit. This is the data which is given to us, and they are asking us to find out the break-even point. So the formula which is used for finding out the break-even point goes like this. The formula is formula number 7 of our list of formula of my previous video. Formula number 7, that is fixed cost upon revenue per unit minus variable cost per unit. If we use this formula here, variable cost upon revenue per unit, if we use this formula, fixed cost upon revenue cost per unit minus variable cost per unit, we can get break-even point for all the machineries, which is like this. For the first machinery, just a minute, for the first machinery, fixed cost is 12,000, revenue is 50 and variable cost is 20. So we can get the quantity, break-even quantity for the one machine is, that is 400 units. Now if we consider 2 machines, then we have to find out the break-even point. Again, by using this formula, we have fixed cost for 2 machines, that is 15,000. 50 minus 20, if we do 15,000 upon 30, 3 5 are 15, that we get 500 units. And if we consider for third machine, again by using that same formula, that is revenue minus that is fixed cost divided by revenue per unit minus variable cost per unit. The revenue which is given to us for the third machinery is 21,000. So if we divide 21,000 by 50 minus 20, we get 21,000 upon 30, 21,000, and which comes to 700 units. So we have break-even point for first machine, second machine as well as third machine. The break-even point for first machine is 400 units. The break-even point for second machine is 500 units, and the break-even point for third machine is 700 units, and corresponding range is given to us. For first machine it is 0 to 300, For second machine it is 301 to 600, and for the third machine it is given to us as 601 and 900. What I have observed regarding this particular problem is students don't find any difficulty while solving the first part. The actual problem with the students, what the students face is for finding the second part, which is the most important part of this particular problem. And the second part goes like this: if projected demand means demand which can be created in future, is between 600 to 650. So what he is trying to ask is that the demand, the exact figure of projected demand is not known to us, but it can be somewhere between 600 to 650. If it is there, how many machines should the manager purchase? How much machineries will be required by the manager if the demand is somewhere between 600 to 650 in coming future? This is somewhat the most logical part if we understand in the whole problem. This is the one of the most logical part. The answer to this particular problem is, from the problem, what the problem says, what the question says, that projected demand is given to us from 600 to 650, and they are asking us how much machineries should the manager purchase. We don't have the exact figure. That is why the question is telling us the range from lower limit to higher limit. Lower limit is 600, higher limit is 650. How much machinery should be purchased if the range is like this, or the number of projected demand lies somewhere in between this range? See, now the for finding out the answer of the question, we will analyze all the number of machines given to us one by one. If we assume the first option given to us as one machine, first option is given to us as number of machines are 1. This option will not be feasible for this projected demand. The reason is very simple. The demand given to us in the question is from 0 to 300. Means 0 is the lowest value and 300 is the highest value. But if we give a little focus on the break-even point, it is coming to us, it is coming as 400 units. So if we understand that the break-even point is 400 units and the range given to us is from 0 to 300, so we can interpret from this that the break-even point is exceeding the highest limit given to us in the range. So first machine is not at all feasible. Try and understand, break-even point is given to us as 400 units and the highest range for first machine is given to us as 300. So we can interpret from this that the break-even point is exceeding the highest range given to us for the first machine. So first purchasing of one machine is not at all feasible. Now if we go to the last part, that is the number of machines given to us as 3. If we understand the break-even point by using the data of given to us for 3 machines comes around, if you understand, comes around 700 units, okay, and the projected demand is given to us as 600 to 650. So if we understand here, or if we interpret here, again the same thing is happening which has happened in the previous part. The break-even point, that is 700 units, is exceeding the highest limit of the range, that is 650 units. So selecting only 3 machines for this given range of projected demand is also not suitable at all. And if we come for the now, as it is clear that first number of machines 1, if number of machines are 1, it is not suitable. If number of machines are 3, it is also not suitable. Now the remaining is number of machines 2. So if we understand here, for number of machines 2, the break-even volume is coming as 500 units. And the projected range for the second machine is also from 301 to 600, and the projected given in the question, and the projected demand is 600 to 650. So so we can say that out of the three data, the data given for the second for the machineries, for the quantity having machinery 2, for two machineries, the data given for the two machineries is somewhat relevant in some aspects related to the demand given for the projections, that is from 600 to 650. But now the real question arises here, that we have come to a conclusion that the data given for number of machine 1 and the data given for number of machine 3 is not at all relevant for the projected demand of 600 to 650. Now the real question arises here, that it is clear that one first part and the last part is not feasible, okay, but if second part we have to use, we are selecting number of machines 2 as projected demand for 600 to 650. Now the real question arises that if the demand is 600, whether it is feasible to use two machines, and if the demand is 650, then whether it is feasible to use two machines. Means number of machines will be same, whether the number of machines will be same for lower demand, that is 600, as well as for the higher demand, which is 650. Now if we understand, or if we take the lower limit of the projected demand as 600, now if we give some bit of stress, or if we try to focus, the number of the break-even point for the number of machines 2 is 500, and the demand is of 600 units. The lowest demand is of 600 units. So there is a bit of scope to earn profit, because break-even point is 500 units and the actual demand is more than the break-even point, that is 600 units. So there is a chance to earn profit by using two machines. So we can come to a conclusion that for 600 number of units we can use two machinery. So it is so as I have told you that it is there is a chance to earn profit, because break-even points are only 500 and the demand is of 600. So there is a gap of 100 units. So if we produce more 100 units on machinery 2 on two machines, we can earn a handsome amount of profit. But in the minds of many students, one question exists, that if we use 3 machines to produce 650 units, whether it will not be feasible, whether it will be feasible or not. I will repeat the question once again, that in the minds of many students this question arises, that if we use 3 machines for producing the higher limit, that is 650 units, whether it is feasible or not. The simple answer to this particular question is, it is not feasible. Why it is not feasible? The answer is very, very simple. The break-even point achieved by using 3 machines is 700 units. And the highest range given to us in the projected demand is 650 units. So what we are doing is, we are producing 50 units extra if we compare the break-even point and the highest projected demand. So we are incurring loss. There is no demand, but still we are producing 50 units extra. How 50 units are coming? Break-even point 700 units minus highest limit of projected demand 650. If we minus 700 minus 650, we are getting as 50 units, which is a loss, because there is only a need of 650, but we are producing 700, so we are producing 50 extra. So there is no demand for it and we are incurring losses. So what is the feasible option? That the manager should produce 600 units only by using 2 machineries. That is the final conclusion which we can interpret from this discussion, that the manager should produce 600 units by using 2 machineries rather than going for any other option. This was the last problem, or this was the thing which we need to conclude. That's it from my side. If you like my video, please subscribe my channel and hit the bell icon for the next videos which will come in the future. I will welcome. If you have any doubts or if you have any suggestions, you can write in the comment box. All the suggestions and corrections regarding anything is always welcome, and I will try to improve it in future videos. Thank you for your time.